Hello everyone, I just welcome to all the generic first sem students to Physics Department Digboy College, and I will be teaching you Unit 2, that is first order and second order differential equation with constant coefficients. So let's begin. So in first order differential equation, at first we have to understand two terms, that is order and degree. So what is an order of a differential equation? It is the order of the highest derivative in the differential equation. And what is the degree of a differential equation? It is the exponent power of the highest derivative in the equation. So we will try to understand this with the help of examples. For example, say I have written d square y by dx square plus y is equals to 0. So here, what is the order of the equation? So if I want to write here, what is the order? It is, you can see here, the order of this derivative is 2. So the order is here 2. And what is the degree? If you see, degree means what? It is the exponent of the highest derivative. So highest derivative is this, and its exponent is what? Here 1. So what we are going to write it as, degree is equals to 1. So this is a very simple example. Let us see another example. Say I have written this equation. I have written this differential equation. So in this differential equation, what is the degree? Okay, so at first you tell what is the order? It is equals to, so we have to see the order of the derivative. So we have to see the order of the highest derivative. So which one is the highest derivative among these three derivatives? Certainly this is the highest derivative, and so the order will be 3. And what will be the degree here? The degree will be, what is the exponent power of this highest derivative? If I say, it is 1. So I have to write again here 1. Let us see another example. Suppose I have written another differential equation, d square y by dx square, and this is square again, plus dy by dx plus 1 is equals to 0. I have written. So what is the order here? Here the order will be, that is the order of the highest derivative. So this is the highest derivative, its order is 2. And what is the degree here? The degree is, so this is the highest derivative, its exponent is 2. So it is 2. Now just see one important example. Suppose the differential equation is of this type. I have written this. So can you tell me what is the order here and what is the degree here? So how to get the order and degree here? So what we are going to do, we are just going to do simple simplification. That is, we are going to do this. So we can write this in this form. This is 3 by 2, and thereafter, so let us do it here now. So we can do here what? That is, we can write d square y by dx square whole thing square is equals to 1 plus dy by dx square and whole thing cube. Now you can justify here what is the degree and what is the order here. So here the order will be what? Which is the highest derivative? This one is the highest derivative. So here we can write what? 2. And what is the degree here? Here the degree, that is the exponent of this highest derivative, that is again 2. So the order is 2, degree is 2. So these were the few examples of order and degree, and I hope that your concept, not completely but somewhat, it must be clear regarding order and degree. So after understanding these terms, let us move to the first order differential equation. So we have some standard methods for solving this first order and first degree differential equations, and these are as follows. The first one is equation solvable by separation of the variables. So we will be discussing this first, and then comes the homogeneous equation and how to get the solution of the homogeneous equation. Then there is another type of equation which we call as linear equation of the first order. And finally comes the exact differential equations. So all these methods we are going to learn one by one. So let us at first see equation solvable by separation of the variables. So equation solvable by separation of variables. Here, if a differential equation can be written in this form, where f of y is some function of y, dy is equals to phi x, where phi x is what? It is some function of x dx. If we can write the differential equation in this format, then we can say the variables are separable. So what is the variable here? Here the variable is y and x. So these two variables are separable here. So the type of differential equation when we can separate the variables in this form can be solved by this method, that is separation of the variables. So let us see an example of this. Suppose we have a question here. Solve x plus 1 dy by dx is equals to x y square plus 1. So this is the differential equation here. Now how can we solve this? Let us see the steps. So at first, solution. Let us see the solution here. So x plus 1 dy by dx is equals to x y square plus 1. This can be further written as 1 by y square plus 1 dy is equals to x plus 1 dx. So here you can see what I have done here. I have just taken to this the denominator and just brought this here, and this dx I have taken here. So in this way I have separated the x variables and y variables, and now this can be solved. So this is what? So this is a function of f of y and this is a function of phi of x, and now we can proceed further. So for that we must know the formulas. Now further what we can do here, we have to simplify it further. So y square plus 1 dy is equals to, this can be written in this way also, 1 minus 1 by x plus 1. I hope everyone must be agree with this. Okay, so I've written in this form. Now my next step will be integration. So let me do it here only. So what I am going to do here is integrate 1 y square plus 1 dy is equals to integration 1 minus 1 by x plus 1 whole thing bracket dx. So if you remember, the formula for this is integration of 1 by y square plus 1 can be written as tan inverse 1 y is equals to, and here if we integrate we will be getting what? X minus log x plus 1. Sorry, it should be x plus 1 plus some constant c. So this is what we are getting. So this is the solution of the differential equation. So this is what our answer is. So this is the way how can we solve a differential equation where the variables are separable. Okay. Now let us see another example. Please note down this. So let us see this question, that is xy square plus x dx So let us see this question, that is xy square plus x dx plus yx square plus y whole thing bracket close dy is equals to 0. So here the solution will be what? So at first separate the two. So this is the question. So we can write it in this way also. Sorry. This can be written further as okay. Now this we can write as x by x square plus 1 dx is equals to minus y by y square plus 1 dy. Please note down this. So now if we integrate it, we are going to get x by x square plus 1 dx is equals to integration minus integration y by y square plus 1 dy. So we can apply here formula, but before that we have to arrange something. So we can write this in this form. The thing will be same only. Okay. Now this can be further written as the, now if we apply the formula here and at this part, we can write it as half log x square plus 1 is equals to minus half log y square plus 1 plus log c, some constant c. So this can be further written as, if you take this side, so half is common here, and we can take log x square plus 1 plus log y square plus 1 bracket close is equals to log c. And this can be, since we know, since log x plus log y is equals to log xy. This is the logarithmic formula. Therefore, we can write what? Half log x square plus 1 y square plus 1 is equals to log c. Or this can be further written as log x square plus 1 y square plus 1 is equals to 2 log c. So if you remember, if we remove log from both the sides, we can write it in this form: x square plus 1 y square plus 1 is equals to c square, or some another constant c dash. So this is the final answer. Let me write the final answer again: x square plus 1 y square plus 1 is equals to c dash. So this is our answer. So for today's class, I will be teaching only this much. In our next class, we will be learning the other methods. That's all. Thank you.